I'm going to throw something at you guys. Well, before I do that, hey, please subscribe. Appreciate it. You're appreciated. Go to National Transportation Board. You can go to their homepage. Watch what I do here. Go to their homepage. From their homepage, type in post-tensioning. Press search. 2 search results come up. That's it. Just 2. And yet we've had multiple bridges have to be redone because of post-tensioning. NTSB is only apparently staying clear of post-tensioning, that they do not want to find it at fault or bad building construction technique. Look, these bridges are only 50 years old and they're going out of service. The one in Walnut Street in Philadelphia had tons of repairs. The one in all of the post-tensioning structures, none of them are lasting. All of them are needing repairs. Cables are breaking left and right. They're not a 100-year bridge. The system is just stupid. It's like having a rubber band, trying to hold you up all the time. It's just ridiculous. The post-tensioning in concrete, the way they're doing it, it's just ridiculous. Here it is, 2 articles. But watch what I do here now. I'm going to hit both of them. Let's see if I do this correctly. Give me a minute to load it up. I guess it's taking a second. There we go. There we go. So let's jump right down here. Evaluation of recovered bridge deck in the vicinity of node 11 and 12. On June 13th and 14th, NTSB investigators and parties, June 13th. The collapse was March, right? 15th. So we got March, entire month of March. There's April, there's May, there's June. 90 days later, to the investigator perform a limited internal examination of the section of the bridge deck in the vicinity of node 11 and 12. 90 days later. It shows they had no urgency, no demands. They just taken their time. An approximately 5-foot section of the bridge deck was cut on either side of the node, 11 and 12. So they took 10 foot of bridge decking, and node section was 11 and 12, right? The 11 and 12 width, which I think is what, 1'9", or is it 2 feet wide? Might be 1'9", and was 1'9", I think. I don't know. It's the width of that the upright, and it was photographed and subsequently documented using 3D laser scanning, which is awesome. But we don't know when did they 3D laser scan it. When it was cut up, broke up, how many times. The internal areas of the specimen were evaluated to determine if the size and location of the reinforcement bars were in accordance with the design plans. So, listen again. The internal areas of the specimen were evaluated to determine if the size and location of the reinforcement bars were in accordance with the design plan. So this is not post-tensioning cables, it's bars, they said. The preliminary evaluation of the saw-cut surface that were internal to the bridge deck and diaphragm 2 revealed sound concrete in the undamaged surface areas and embedded reinforcement steel consistent with the reinforcement prescribed in the final design plans. As I understand it, this is that number 7 that they can no longer find, that they can't find a specimen that was able to evaluate. That this is part of their, let me see if I can get you diaphragm number 2. So this would be diaphragm number 2 here, as I understand it. And they cannot find stirrups or anything like that of number 7. I only understand it that number 7 is the stirrups. I don't have that finally locked in, but it appears that number 7 of the stirrups, they're talking about embedment here, and yet they clearly make it clear that they cut out a huge section. They transport it. 90 days later, they photographed and laser tracked it. The preliminary 3D grafted. The preliminary evaluation of the saw-cut surfaces that were internal to the bridge deck and diaphragm 2 revealed sound concrete in the undamaged surface areas and embedded reinforcement steels consistent with the reinforcements prescribed. All right, so when you do a saw cut, you get to look at both sides of it. I don't know if I did a few videos showing that, but I don't know if I ever showed it to you. And you look at the profile, and you want to see, the air entrainment. You're looking for cracks, things like that. and hopefully you get a nice profile of what's going on. That's what you're looking at there. Photographs of cracks. The NTSB preliminary report. Watch where I'm going to drive something else for you guys. The preliminary report, right? Photographs of cracks. Let me pause this and let me jump to it. Hold on. So I want to do another post-tensioning video for you guys using a box or something like that. I got a fish tank. I'm doing a few videos using this fish tank. It's driving me crazy. I don't want to trash the fish tank yet, but it's going to show soil compression, things like that. All right, real slowly and quickly. If you have separation, your post-tensioning is not working anymore. Your post-tensioning is not working anymore. Your reinforcement goes from one, throughout this deck, and canopy and etc. in the uprights and verticals and diagonals. The reinforcement, the tension cables, if they become elongated, then we get cracks. If they do not become elongated, if they do not give, they do not heave at all, they do not become more elastic at all, then we can't have a crack because there's no room for the crack to develop. The crack can only develop if you have loose post-tensioning cables. Your cables are becoming slack, and that's because of loading, or you have breakage or slippage in your connections. And I'm saying connections because it might be some mid-span connections in there, although I doubt it, but there just might be some type of coupler in there. Now let me pause it. I'm going to do one more thing for you. Hopefully I can find I'm trying to find, and I'm hard to find, to show you how cables, when they're wrapped, if you have, just like a racetrack, if you have the inner track and your outer part of the racetrack around a curve. The one around a curve has a bigger distance, tighter radiuses in the inside. And so you can imagine the forces on each one will be different. Just like a race car, the forces will be different on a cable also in that radius. The amount of friction they pull on each other will be different also. The man on the bottom is going to pull more, won't he? He's going to have more load on him because of the cables on top pushing down on the man on the bottom. But will that then take the stress off of him? The man on the bottom, the cable on the bottom. So just to visualize the cables. Because when we look at cable failures in structures, there's often 1-2 cables popping out of a bundle. Why aren't they all failing at the same time? If they're all in the same stress, then how come they're not failing at the same time? Because they're not under the same strain stress. They came from the same reel, a lot of times the same reel, so you can't say, well, that cable must be weaker than the other cable through manufacturing. Well, if you do tell me that, I'm saying that's too much of a random problem. This whole video is to show you that post-tensioning is the problem. It's just, they need to abandon it. They started in the 50s. They need to throw it all in the trash. Go back to steel. That's the suggested a video. And now can NTSB slander and slap around post-tensioning like I can? No. No, they can't, because there's too many bridges with this post-tension girder systems in it. It would have to be retrofitted, replaced across the country. And that's going to be quite a few billions to get rid of all this junk. There's my